Our assignment was to assume that the minute hand of the clock is 15 millimeters long and the hour hand is 12 millimeters. We had to determine how quickly the distance between the two is changing as the time is 2 p.m.
Okay, because there are 12 equidistant points on this clock, and we know that the entire clock is 360 degrees, we can divide 360 degrees by 12, which is 30. Yes, okay, yeah. Which is 30 degrees, and then multiply it by 2 because it's 2 o'clock. And so now that we know that this angle is 60 degrees.
Okay, the minute hand and the hour hand are constant values, so they're not going to change. So dA dt and dB dt are going to stay constant, so 0. What we're solving for is dC dt, the rate of which it changes. So just to redraw the triangle that we're solving for, it looks something like this. That is the minute hand. That's what we're solving for. We're solving for C, and then that is the hour hand.
Okay, so now we know that one hand of the clock is 15 millimeters long, the other hand is 12 millimeters long, and the angle between them is 60 degrees. So we can do law of cosines. So c squared equals a squared plus b squared minus 2ab cosine of angle C. So now we're going to plug in our values. Unknown c squared equals our first hand squared plus our second hand squared with 2 times the first hand multiplied by the second hand times the cosine of the angle between the two, which is 60. So when you do that out, good. That answer, which when you plug it into your calculator is equal to about 14.798.
So now we have to take the derivative of the law of cosine. The law of cosines is c squared equals a squared plus b squared minus 2ab cosine of angle C. So the derivative of that is going to be 2c dc over dt equals 2a dA over dt plus 2b dB over dt minus 2 times dA over dt b cosine of C plus dB over dt a cosine C plus AB times negative sine C dC over dt.
Angle is how much the angle changes every hour or every unit of time, which is 390 degrees because you have one full rotation for an hour of the minute hand, which is 360 degrees, plus 1 hour of rotation for the hour hand, which is 30 degrees. So 360 plus 30 is 90.
As you see, these values are 0, so any place in this equation that has that value is going to cancel out. So this cancels out, that cancels out, that cancels out, that cancels out, and that's everything. Now the new derivative equation is 2c dc over dt equals 2ab sine of angle C dc over dt.
So now we plug in our values. So 2 times C, which is our calculated value, 14.7986 at 2 o'clock, times the derivative of C, which is unknown, that's what we're solving for. So C equals 2 times the first side, which is 12, multiplied by the second side, which is 15, sine of the angle, which is 60, multiplied by the amount the angle changes every minute, which we discovered to be 6.5 degrees per minute. So now, because we can't do this in degrees, because we can't tilde speed, sine of 60 to sine pi over 3, then get this into radians by multiplying it by pi over 180. And the rest of the equation. It's the same. There we go.
So next you have to plug and chug, and you have to divide the top by the left side of the equation, and you get your answer